Hello students, welcome back to the video lecture. This is unit number 4, digital modulation schemes. The course outcome of unit 4 is analyze the spectral characteristics of bit error rate performance of digital modulation techniques. So in the previous classes we discussed about various modulation schemes and their probability of error, bit error rate and the corresponding signal space diagram. So in this lecture we are going to learn about carrier synchronization. So this is a different topic from the previous lectures. So as we discussed, synchronization is nothing but we have to synchronize the carrier frequency which was used in the transmitter. It has to be used in the receiver section also. The same carrier frequency has to be applied in the receiver section. That is carrier coherent reduction, coherent synchronization. So here carrier synchronization is similar to coherent detector synchronization, whereas the only difference is we are not directly apply the carrier signals at the transmitter receiver side. Instead of that, we are going to reproduce or recover the corresponding carrier frequency by the system itself. So the modulated signal will contain the carrier frequency Fc, and the receiver will log for that particular frequency Fc to reconstruct the signal. So this is the concept of carrier synchronization or carrier recovery. So instead of giving the carrier frequency in the receiver section, we are using one phase locked system to lock or fix our same carrier frequency. That is called as carrier recovery. So this carrier recovery can be done by two methods. One is nth power loop and the second method is Costas loop. So in nth power loop, the basic blocks are input signal, mth array device that is used for multiplication. Whatever you are giving the input signals, input bits, the same thing can be obtained. Like our square law device, it will power the square the power level. If we are going to use m array as m is equal to 4, that is the number of bits are considered as 4, then x of t is going to be x of t power 4 times has to be taken. Similarly, if it is 16, then m is x of t power 16. So the power levels are increased based upon the requirement. Here m array psk x of t is given as the input. M varies, depends upon the user constants psk. For carrier synchronization or carrier recovery, phase shift keying method is considered because here we are modifying the carrier phase with respect to the input signals. And one more thing, here after the power level converter, we have one important filter which is called as band pass filter. So this band pass filter used for only allowing the required carrier frequency Fc. The remaining unwanted frequencies are eliminated with help of this BFC. So the higher order harmonics after this power level converter are eliminated except the carrier frequency. So in this step itself we identify our carrier frequency, but that carrier frequency has to be maintained throughout the transmission. So for that we are introducing a phase lock loop which is called as PLL. So we know the operation of PLL. So one input will be provided for the multiplier. The multiplier receives the feedback signal which is negative feedback. The negative feedback signal from the output of VCO. So that particular frequency and the input frequency are going to be matched, and the desired frequency FC is locked with help of this PLL network. So this low pass filter will allow only the required frequency. So the unwanted frequencies are eliminated with the help of this low pass filter. Then after locking the frequency, we are using frequency divided by M, because in the input side we introduced the power level as M, so that has to be eliminated in this side. So we are using the same M value in the frequency divided block. So say for example, if we are using M is equal to 4, here the frequency divider device is divided by 4 from the output of VCO signals. So from this we can achieve our carrier frequency FC. So in this way we can able to recover the carrier frequency FC instead of applying FC in the receiver side. So this is one method of recovering the carrier frequency. And the second method is Costas loop. So most of the operations are similar to the power loop, whereas here we are introducing one phase shifter. That is, here the modulated signal is given to two multipliers. One is directly given, the another one is phase shifted for 90 degree, and which is given to the product modulator. So if it is receives cos 2 pi FCT, the second multiplier will receive sin 2 pi FCT. So that is the only difference. So we are phase shifting the input modulated signal at this step. Then this next step is low pass filter. So the low pass filter is designed to allow only the desired frequency, that is nothing but carrier frequency. So that is given to summer block. Here also we are using one VCO. This again act as a phase lock loop. So the output from the summer block is given to the low pass filter. So this low pass filter, narrow band low pass filter, allows only the low frequency signal, which is nothing but the required FC, and VCO is locked for that particular carrier frequency, and again that is going to be given for the phase shifted. So the output feedback signal produced by the summer block is going to be again phase shifted. This acts as a carrier frequency in this side. So we are not applying the carrier frequency directly. Instead we are using a phase locked carrier frequency with the help of this block. So this is the operation of Costas loop. So the mathematical expressions are given below. Vm is equal to 1 by 2 root e by t cos pi minus theta into 1 by 2 to e by t sin pi minus theta. So here it is phase shifted. So here it is cos, and the lower network which receives sine. So when we simplify this, we will get this equation. So we can say that the power level is equivalent to E by T. So Vm is equal to P by 4 sine 2 pi naught into theta. So we can achieve the modulating signal alone at the output side. So this is how the carrier is recovered with help of Costas loop. So once again I revise this topic. Carrier synchronization is nothing but, instead of directly applying the carrier frequency in the receiver section separately, we are introducing carrier recovery method. So in carrier recovery method, the carrier frequency is locked by using devices in the network itself. One is phase lock loop, another one is Costas loop. So in this way we can recover the carrier signal. Thank you.